I'll just wait for 5 more minutes before we start.
Okay.
So you're commuting from work, or
I mean, I'm coming home. Yeah, no, actually, I went to a CFA event, so I'm
uh,
on my way from San Francisco.
oh, so it'll be like
Yeah, it'll take like,
1 2 hours.
yeah.
But
Yeah,
unfortunately,
I think I'll
today's
reach,
class
yeah.
will mostly be hands-on because it's
Oh,
our
yeah, I thought so.
because it's
Yeah,
programming, right? So we'll
yeah,
actually.
true, true.
And so, okay, I anyway started recording it, so we should
Okay.
continue this thing. So did you get a chance to like go through the rest of lectures on Sunday?
Yeah, I did, and I'm doing still on my assignment, so I'll just send it by next week or
Sure,
something like that.
sure.
Yeah,
So I think like,
yeah.
but overall, like you have a fair understanding of how the machine learning problems are, what we need to do for uh, like in
Yeah, yeah.
yeah. So I guess like that is the like main part. Today is just an additional introduction to R programming. So mostly we'll be
Okay.
covering like R functions. How do you actually install modules? How do you write modules? How do you use R functions to actually graphing and everything? So it's going to be
Okay.
an introductory class, and then we'll do 2 case studies in R for the next class, so that you'll have an
Okay.
mainly on linear regression and logistic regression.
Okay. So I'll be sending my resume to you. So can you just forward it among your network and
Yeah, I will.
see if they have some more?
Yeah, so you can forward me to my Gmail, uh,
Okay.
like the one which you get the notifications from.
Notification. Okay.
Yeah,
Yeah, I'll send it to you.
okay. So you won't be able to see.
Yeah, I won't be able to see anything. I just wanted to like. I mean, like I think I missed one class already, so I did not want to miss
Yeah,
another one now.
no worries.
Mhm.
So, but unfortunately, like today's class is the one
Yeah, I know.
you'll have to do
But
a
but
lot.
the R Studio is that we have
Yes,
to install the.
yeah, R Studio installation, and then it's mostly going
Okay.
to be like hands-on practice, like starting with our variables, functions, lists, modules, installing modules,
Okay.
uninstalling modules,
Mm.
and then doing so basic, so that basic familiarity. Because mostly again,
Okay.
like Python, we'll be using standard packages in R,
Okay.
so we'll be
Okay.
planning to do that.
Okay.
So yeah.
Mm. So Sai, have you come across anybody who have just done some courses without a master's degree, get a job in this or like an internship?
Uh,
Oh,
without no, actually, so the most people who have they are actually working, and then they shifted to this area. So
okay.
basically, your work X is what you need to highlight, and then
Okay.
do basically show these courses and everything, and then basically like it's mainly interviewing, right? So interviewing for
Yeah.
these positions and stuff. So, and if not like this thing, then other role is basically program management in data sciences. That is one other area,
Okay.
which is basically you need not be the data scientist, but you can actually work with data scientists to actually
Okay.
solve the current issues and stuff. So it's called
Okay.
basically business analyst and stuff, positions like that.
Okay.
So
Okay.
those are the other positions. So if you're actually going into data science completely, then I think it's basically then it's like a lot more practice of case studies and stuff like that. But I think
Okay.
business intelligence and business analytics, so that is the space where you can find more opportunities right now, because at this
Okay.
particular point of time you understand what is being done. So it's basically understanding the requirement from clients and then working with data scientists to deliver projects. So that is the area
Okay.
I would recommend to target. Because if you want to go
Okay.
completely as a data science programmer, a little bit more of this thing is required. I mean, as in like
Okay.
projects on data science and stuff. But then business analyst positions are really basically are a good opportunity as well. So
Okay. Yeah. That I'll start looking for opportunities in that area.
sure,
Thanks, Sai.
sure, no problem. Hey Jatan, how is it going?
Yeah, good evening, guys. Going good.
Yeah, you missed some lectures, right, in the past?
Yeah, I missed quite a few lectures. Sorry, my kids are missing.
Yeah, but did you get a chance to go over the video lectures?
Yeah, I have gone through it. I still 3 lectures to go.
Okay,
But yeah, I have gone through the different tactics and everything,
okay,
and I have, I mean, good graph on that one. So probably I will have
okay,
some list of question. I will send it to you by email, or I will ask you, sir.
okay. Then we'll do that. So today's class, so this is the last of the 2 classes we have. So today and then Sunday is our last class on for this thing. Basically, today's class we're going to, because ideally we wanted to do Python and R initially and then go into like case studies and stuff. But then I think most of the people felt like, because they just learned Python, right? So they don't want to learn another programming language and get confused with the other programming language as well. So that's why one of the main reasons we postponed R to a later stage is because of the fact that we wanted to. So I think right by now, I think Python libraries, I think we have like really good practice in Python. So that's what we wanted to do: 80% Python and 20% we wanted to do R. So there are 2 case studies on Sunday. We'll take a look at them, and those will be completely done in R. But for today's class, we're going to have a lot of hands-on things. So if you are not on your computer, I would recommend you to like stay on your computer, and basically we'll walk through the installations and we'll see. So generally, whatever Python can do, even R can do. So most is, but then R has this more flexibility in terms of data science, because it's very similar to like MATLAB programming language, and most of the students learn MATLAB in college, and then it's picking up a lot more in academia, and then so most of the stuff R, they don't use it for production purposes, but if you want to do a quick test to see which algorithm to use, or like quick anything in which you want to do a quick analysis, they use R, because it's very again, it's also very simple language to learn, and it's generally used mainly for experimentation purposes. So mostly experimentation purposes they use this, and Python is mostly used for production, like they build Python learning engines and stuff like that. So but then R has been picking up, especially in data science. So R is only useful in Python. You can do a lot of stuff. You can actually build web services. It's a full-fledged language, right, Python? But R is exclusive language for data sciences. So that's why I thought like it'll be good to just give an introduction, at least to an extent where uh, we can actually port libraries and run data science projects and stuff like that. So that's why today's class will be an introduction to R, and it'll be mostly hands-on. So as I said, like yeah, if you're away from your computers, if you're learning it on the phone and stuff, ensure that you have a computer near you to follow with along with me. So going into today's class, as I said, it's in programming in R class. So a little bit about R. So basically, there was this language called S. How many of you know Bell Labs? Bell Labs is very famous lab. I think MIT actually has Bell Labs. So they actually do a lot of data science, this thing, and a lot of things have been created at Bell Labs. So they actually came up with this interactive environment called S for data analysis in 1976. So it was a very old language. It's called S. It was mainly under the covers. It was implemented in C and Fortran, but there was this interactive environment called S. So R basically, because MNOPQRST, right? So R is an implementation of S language with So it was basically from S, they actually removed certain parts and added certain things. Like they added a lot of semantics which are more user friendly and stuff. So that's why the language name is R. It was initially developed by University of Auckland in New Zealand. So uh, basically they are a team of like 15 people who actually started full-fledged. So when they saw that it is gaining more and more popularity because of its simplicity, they kind of made it into a core team with 15 people in 1997. But now it's like a full-fledged language, and especially in the world of data science, R has been picking up pace. And also not only picking up pace, but it's most of anywhere you go in industry, right, the first kind of experiments they do they before they want to productize something is basically in R. So there are nowadays even like, so most of the cases where a lot of machine learning teams, what they do is they provide these services and write them on the cloud. Like for example, Azure has Azure ML, which is like a machine learning device on the cloud. What they do there is they generally host services and then expose them as REST endpoints. So anyone who wants, they have data and then they want to have some analysis, right? They just send the data to that service, and then the service will run on the cloud, which actually has uh, everything implemented on the cloud, and it'll give you back the results. So most of the data learning startups who want to expose their uh, algorithms to the public or to expose their algorithms to companies, they actually are using this. So uh, Azure or the cloud implementations now can actually host Python and R web services too. So basically what that web service does is you can port your code completely in whatever Python code you have written, whatever R code you have written, you can just host it on Azure ML machine, and then there's a web service which will pass the data. So what does that machine have? The machine only has the algorithm. The data has to come from the client, right? So basically the client can package all the data as a JSON object and then send it to the web service, and then that web service will basically take that data and run the algorithm there and give it to you back. So given the popularity of R, they're now adding provisions for writing things in R on the cloud as well. So that's why it's important to learn. At least if you don't need to, you can choose one language. Like any language is fine. Python is also good, but it's good to understand this because most of the cases when you want to do a quick prototype, uh, so R is being used in a lot of industries. So if someone actually gives you the prototype and then says, hey, can you decide? So you at least need to be familiar with the syntax of what is going on and how to use it. So that's where this lecture today will be strictly focusing on the basics of R. Like we'll start writing some programs, we'll see how to load modules, all the stuff which you have done in Python. There are R libraries, corresponding libraries in R as well. So again, it's your choice of language, right? So if you feel you're more comfortable in Python, I would say still stick to Python, but have familiarity in R, because in case if you come across like different organizations have different uh, ways of implementing, especially with us, we basically do everything in R first and then prove that yeah, this works, and then we go and implement it in Python and stuff like that. So yeah. So again, why R? So it's firstly an interpreted language. So we even saw that Python is an interpreted language too, right? So you don't need to convert like it directly. There's an interpreter which converts it into the machine level bits. So there is no compilation again here. So it's similar to Python. Even in Python is an interpreted language. That means an interpreter can convert the human readable language directly into bits. But whereas other languages which actually they need a first step of compilation, the language gets compiled into bits and then it gets interpreted. So in this case, that step is gone. So you write the code, there's no need to compile the code, and you can just run the code. And also there are like really cool things in R Studio which we can do is we can select a few lines of the code which we want to run from in the middle of the file and run it. So it's very so in Python and stuff you have to run the whole thing, right? Remember initially when I was doing like multiple graphs. I wrote everything, and then in order to show the last one, I still had to run through like the first, second, third, fourth graph, and then come to the fifth one. But in R now, I can write everything in one. I can select in the middle of the file, I can select one segment and just press Control Enter. It'll run it automatically. So that's one additional ease with this thing. It's also open and free. So it's free and open source software. It has a lot of packages. That's one of the main crucial reasons. So it provides a very crucial infrastructure for producing, loading, and maintaining these software libraries. So there is this thing called CRAN. You can actually go, I'll give you the link for it. It's called http cran.r. So all the R packages and everything reside there. So whenever you want to install a package, it goes, talks to the CRAN uh, open source database, and it gets you all these packages and stuff. So it's one of the leading languages for statistical and data analysis. A lot of people who actually write their packages in Python also are putting them on R. It's mainly created a lot of curiosity and very popular among researchers and universities because it's only second to MATLAB for graphics, and it has a very active user community. So since it's open source, a lot of people contribute uh, to the language. It's very good for simulations, programming, and anything which actually can efficiently provide data analytic solutions. People use R for this thing. So given this background, again, I'm not, so it's up to you uh, to choose. I personally prefer Python because it's more, once you write everything, it can be easily produced. You can make a Python engine out of it and this thing. But as I've seen over the course of few years, R has been like the language for basically experimentation. So because it's really quick, so you can, so the very fact that I've dedicated only one class for this should tell you like it's really easy. And especially for college students, if you're in college or this thing, it's very similar to MATLAB is extensively used in college. Even when I was in college, we used to use MATLAB quite a bit, but MATLAB is not open source and it's not free. So they wanted to develop something analogous to MATLAB, which is open source and free. So R has been picking like popularity uh, quickly. So I am not going to use a lot of slides today for this thing because that would basically be me saying something with the slides. So quickly install RStudio. So RStudio is basically the medium in which we write our code. So RStudio looks like this. So this is the link for RStudio. So let me, so this is the, I'll send it to you over chat also, but if you can see my screen, you can just download RStudio from here. It's https www.rstudio.com/products. So I'll also send it the chat message to everyone. So quickly download RStudio, and this is the source where most of, so I said right, CRAN R project. So this is where most of the R libraries are written. So you can take a look at it when you have some time. But generally, if you download RStudio, it actually interfaces with this CRAN R. So you can basically, so firstly, you can download R. So it says download R for Windows if you're using Linux or Mac. You can actually download the whole. So you need, as I said, right, like I the library, the studio or IDE for running the code is RStudio, but you have to first, it's again an interpreted and a scripting language. You can just download R first. So you go to like downloads for R, and then you can actually say install R for the first time, and you can, it'll give you like what is the version and everything you want. So you can download, so the version we are using today is 3.5.1 for Windows. So you can just download the package for like Windows or whatever language or whatever OS you want to use. So you click that and you can run R first, and then after you do that, you install RStudio. So RStudio is this really cool IDE which you get for R. So most of it is free unless and until you want to download a professional version. So you can just download the free version, which actually, so it's called RStudio Desktop Open Source License. So if you want to use open source license, you can just use that for now. So you see it is here, download now. You'll download it. So please install R and RStudio quickly, and then I'll show you like where is the console, what are the terminals in the RStudio, and how do we like execute code in both of them. Did everyone get the links?
Yeah.
Okay. Any questions on like where to download them from? So basically for R, we go, I mean, if you're using Windows, you can do that. But if you're not, if you're using anything else, you can download the corresponding version. So once you install R, then we'll just go through the basics of R in the first class, in today's class, as to how we can write small functions, how do we write loops, how do we load libraries, and how do we do basic plotting mechanisms, how to do read CSV and stuff like that. So today's class is mostly hands-on on the R portal. So I'll give you guys like a couple of minutes to download and install. Any questions on how the installations will work? So Meher and Satya, you guys are in college, right? So you guys,
Yeah, I'm here, Anna.
no, but you actually are familiar with R, right? Or do you guys code in R?
I am in high school.
So they don't teach R in high school?
No,
Okay.
we teach Java.
Yeah, that's a programmer. So R is mainly a dedicated language for data science. Yeah, that's okay. Like you can be on mute and you can still go. So yeah, basically, so first thing, downloading R for Windows, or if you're using Linux or Mac, you can download R from any of them. So CRAN is the portal where most of the R libraries and everything are there. And once you install that, so we will start with RStudio. So RStudio, I'll show you how to like create scripts, what to type in console, what is an interpreted language, and like how do you run things using the interpreter directly, how do you run R scripts and stuff like that.
Sorry, I missed the installation part. Can you just?
Sure. So I sent it on the chat. I can send you again. So there are two things. Firstly, you need to install R. So the link for R is HTTP. I'm sending it on the chat message again. So this is where you download R from. So you click on this link, you get to R, and then you can choose which OS you want, and then download the latest version. This will install R as such. So again, you don't need RStudio to run R. You can actually just launch R in command prompt and run it. But most of the stuff which we have seen, we need a decent IDE for running any of the language, right? So we'll basically use RStudio for doing that. So, and then for RStudio, this is the link.
Oh.
To download RStudio. So first install R, and then you can go to RStudio. In RStudio, don't download. So as you can see in my screen here, don't download the one which has a commercial license, and don't download the RStudio server. We want RStudio desktop, and you can see the download actually starts from here. You click download and install, it'll install it for you. These are the two links for the downloads as such. So while you're installing, I'll just go through. So you don't need to pay much attention to this. I'll just go through the basic structures in our data types and stuff, so that while you're installing, you can still follow this thing. Once your installation is done, we will start coding. So basically, again, in similar to like Python, you don't need initialization here. So like in Python also, we don't have initialization, right? We don't say int x equals something in this thing. So the data types are by default implicitly created by the interpreter itself. So you don't need to actually exclusively specify what the data types are. So the variables are not declared as some of the data types. Most of the variables are assigned as R objects, and the data type of R objects, it actually determines the type of your R object during runtime. It's very similar to Python. So if you know Python, and R and Python are kind of very similar, because even in Python, we don't have data types. We don't have like integer. We don't need to declare integers, floats, and stuff. So you just create a variable and assign the value. During runtime, the interpreter figures out. So if you're assigning 5.0, it'll figure out that this is a variable of type float. If you assign 5, then it'll figure out that this is an integer. So depending on the type of value you assign to your variable during assignment itself, the interpreter will figure it out and will assign it to you. But there are a lot of frequently used R objects. Like for example, similar to Python, we have we have something called as vectors, lists, matrices, arrays, factors, and data frames. So we will go through each one of them. We'll write code and we'll see what each one of them stands for. These are the basic data types. Basically, you can create lists, vectors. So I'll tell you what a vector is, what a list is, what is the difference between both of them. Why do we have arrays and why do we have matrices, both of them differently? And then there is something called as factors, which is for categorical variables, and data frames. So let me know once your installation is done, then I will go into these in detail, where you will also start coding for each individual data type. How many of you are still installing? I'll wait for a bit till you install. All right. There is no hurry. We have enough time. We will basically. So generally, what I've observed is when you are live programming and stuff, you're like it's not, you can't follow more than like an hour or two, because you have to type and everything, right? So we have so next class I will show you how to create an R web service and put some code there so that you can call using the web service. So today's class we will spend some time it's very important to get the installations right, because if your installation is not right, then everything, like no matter what we do, again it will have to go and reinstall and stuff. And I don't have much slides also. I just thought of introducing R and their data types. Most of the stuff which we'll do is like hands-on. I'll show you the code and we will write the code for each of them. There is one thing in R, I'll let you guys figure this thing out. I'll show you, as I told you also, right? Like there are a couple of things. You can write the whole program and you can run like 2-3 lines within that program. So you need not actually, because it's a scripting language, right? So you you need not actually run the whole program as such, but you can run certain portions of the program. So while the installation is happening, I'll talk a little bit about these data types. So firstly, there's something called as vectors. So what is a vector, right? A vector is a collection of similar items in one. It's like a list, but then it's a collection of similar items. Like for example, if I want to have like, so there's not much difference between a vector and an array, but it is a one-dimensional. So vector can be thought of as one-dimensional array, right? So anything you need to actually quickly write, you'll create a vector. Let's say if I have 10 numbers, so I'll create a vector of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a vector is nothing but a collection of similar items which you can combine. So there is this one operator in R, which is not there in other languages. It's called the C. So C means combine. So whenever you want to write something like, I'll just show you here. For example, if you want to create a vector, right, of like different variables, you can see here. So one thing in R is recently people have changed. You can use equal to, but R always has used this arrow symbol to assign. So you can actually replace it with equal to also, because recently they've changed it to use that, because assignment basically to make it more clear, they actually use this, less than, equal to, and dash. It's like an arrow. That means that this particular thing is going to be assigned to this particular variable. So instead of giving equal to, they have this arrow symbol. So which is something unique to R. So how do you differentiate if it's an R code? Whenever you see this arrow symbol, right, instead of using equal to, people start complaining like, oh, if you are actually using that, then what equal to? So now they support equal to also. So, but then I thought I'll let you know, because whenever you see this arrow symbol, you should know that it is R. Most of the old programmers or people who actually learn R properly, you still use the arrow symbol, which is less than and then dash, which will take the value on the RHS and put it onto the LHS side. But for your convenience, if you don't want to use that, you can actually still use an equal to sign. So basically, creation of a vector. So there is this operator or this function, you can say, which is basically called C and braces. So what this does is it's called a combine operator. So when you're creating in general, when you're using like in C# or Java, you have to create int square brackets x equals new int of something. Here you don't need to do that. You can just use the combine operator. You can give in your, here for example, in this case I'm combining colors and I'm saying different colors of apples. There's a green apple, yellow apple, red apple, red apple, red apple, and green apple. So you just use the combine operator and then put in all these words into that. We'll code it, but I just want to tell you the difference between each of the individual data types which we have. So a vector is something which we will use to actually combine objects of the same kind and put them into one object. Like it's very similar to an one-dimensional array. So mind you, it's only one-dimensional. So combine operator only works one-dimensional. So that's why we have a vector. So now the next operator is a list. So it's very confusing to know like why do we have a list and a vector. So the difference between a list and the vector is a list is again similar to a vector, but a list can contain objects of different kinds. Like for example, if I'm creating a list, I can create a list which is which can be a vector. So let me show you how to create a list. So if you're actually, or maybe I have one. Look at this. So I created a list here. A list, basically the way you create a list is by saying list and then simple braces. Sorry. List and simple braces. In this list, you can put anything. I can put 2, 3, 4.0, like I can put different data types into this thing, and then I can put a vector also in this. In this particular thing, I'll put C of 3, 4, and 5. And how do you actually assign it? You can do equal to, or you can put the arrow sign, so which is like less than equal to, and say my list. So difference between a vector and a list is basically the fact that a list can contain combinations of different data types into one. So a list can, so in this case, I even can put like a sinusoidal function. So I can even put a, like, the function of a thing into a list. So anything can be put into a list, like, but a vector, you generally put similar, you put like items with the similar ones in a vector. That's the difference between a vector and a list. And then similarly, matrix is always a two-dimensional array. So the way you create a matrix is again by calling the matrix command, and then you put, so how am I populating it? I'm always using vectors to populate it. That's why I started off with the vector. So in the matrix, I create a vector and say A, B, B, C, 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 and I can give it number of rows and number of columns, and then you can actually print. So wait, at this point, did you guys finish installing?
Yes.
Okay, so let's start by writing a small vector. So, okay, before that, I need to show you what is this RStudio, right? So when you launch RStudio, there are few things which you will see. So firstly, at the bottom, can everyone see these windows? So if you don't have any, these are R scripts. So, or else if you actually first start the RStudio, you will see a console and a terminal. Terminal is nothing but your command prompt. Like, when you actually launch a command prompt, we won't be using the terminal much, but in your console, everything which you can type in a R script, you can type it in a console. Like, for example, print is a standard command. So print, I will say my name is enter. Oops, sorry. So I can actually give in any variable as such also. So I create like my string, and I can assign whatever to it. So you can, so a console is nothing but if you want to type in individual commands, right? Like hello world, or even you can type your whole program also. It's similar to like the Python console, in which you can type in the whole program into the console. So console is mainly used for either installing packages. It's mainly used for writing. You can write your whole program there, but you will execute one by one. So first thing what you need to do is, before you write anything in the console, let's write a script. A script is nothing but like your like in case of Python .py file, right? In this case, it's a .r file. So how do you create a script? You create file, new file, and then say R script. So this is the brand new R script. So in this R script, so like we do every single time, let us actually print out, let's say print out hello world. So first what you do is you create a string. Say my string. You can, mind you can give you equal to, or I think let's just give equal to. I don't want to confuse you with the arrow operator. You can just give equal to and type in my name is something, blah blah blah, and then just print out mine. Print so is everyone able to create a R script? So whatever you have in the R script, you can actually have it even in the console also. So basically in the console also you can type this whole thing, but the advantage of R script is you can execute all the lines together. So everyone create an R script first, just print out just print out hello world. So just say hello, just to ensure that your installations and everything worked fine. How do you create an R script? You say file, new file, and then say R. So it will basically say untitled1. You can again save it anywhere you want, but quickly create a small R script. In this case, what you do is you create a string. Just for the sake of it, if you want to do it, you can give the arrow operator also. The arrow operator means that whatever is here on the right hand side, you will put it on your left hand side. And then there are two ways to run this. So this is something which you will learn. So when you there, if you can see here, there is something called as run, and there is something called as source. So the difference between this is if you hit source, if you hit source, the whole script will execute. I don't want to save it for now, but if you hit source, the whole script will execute. When I hit source, say it printed out hello world. But if you hit run, wherever your cursor is, it will run from that particular point. So it basically, if I hit run here, it will execute one thing at a time. So I hit run, you see the cursor moved down. The first statement which it executed is hello world, and it just assigned it to my string. When I hit run again, then you will actually, it'll print out this thing. So difference between running source and hitting run is the fact that run will only execute them sequentially. So one by one by one, it'll execute. But when you hit source, it'll execute the whole script at the same time. So you can just play around with this. So now I can just say my name. Put in your name. So I'll just put in my name, and then I'll say my role. So again, mind you, we don't have I'll just say SD. We don't have data type initialization, so you don't need to say string my name equals this thing. When it sees that you're assigning a string to this, the interpreter automatically assigns a string into this thing. So then I can print my name. Want to save it. The thing I want to show you here is if you actually have two sections of the code, right? If you have two sections of the code, you can actually control select which section you want to run and run it. Like in this case, if I just want to run this part of the code, I'll just do this and do control enter. It'll only run that portion of the code. If I want to run this portion of the code, I will just do this and then hit control enter. It only run that portion of the code. And now when I hit source, what will happen? So source, when you hit, the whole script will run. But if you want to select certain portion of the code and want to run only that, then you will basically, you can select this and just hit control enter, you can run that. Is that clear? So just quickly write some print statements and assign some strings, and then we will see how you can run this. So get some familiarity with the IDE first. So when you launch RStudio, so the same thing you can do it in console also, but console it'll run one step at a time. It's like execute one line, second line, third line. So now if I actually print out the same thing, I can do here also. So I can basically take this, copy. If you want like something really quick, then that's when you can run it in the console also. But generally, you know, like we like executing whole things in one. So that's why we create file, new file, and you create an R script. So the things in R script which you need to know is, one, it doesn't need data types. Second, you can either use equal to operator or you can use an arrow operator. So arrow operator will actually take the left hand side and put it on the right hand side. So, and then you can run any portion of the code. Like if you just want to run this line, you can just select that line and press Control Enter. It'll only run that line. And also the same thing you can do using the run also. When you hit run, only that line will run. It won't run the whole thing. And when you hit print, it will run only that line. So if you want to execute somewhere in the middle, you just go to run and hit those things. If you want to execute the whole thing, hit source. Source will run the whole thing. Is that clear? Is everyone able to run these things?
Yeah.
All right. So this is like a basic R script. So there's nothing fancy about this. We actually go and like run the basic stuff. So the advantage of this is I can write all of my code in the R script, and then I can either hit source, or I can write everything and I can just show you like individual stuff when you want to run. I can just select this thing and then I'll do this. It'll only run that portion of the code. So things like that. So now having said that, there are like the 5 main data types. We'll just create some data types right now and then run them one by one. So the first data type is vector. How do you create a vector? So basically you create a vector with this function called C, which also stands for combine. So combine multiple things into one. So you can see that once you get used to R, it's very difficult to move away from it. It's because it's so easy to start typing and then running it, right? So a lot of people I know, they refuse to like code in any other language because if they're doing pure data science, so it's only for data science analytics, right? So if you're doing data science projects, they just use R. They don't use anything else because it's easy to prove a concept. So like for example, I have this file. So create one more file. So I put in all the data types which we discussed here. So the advantage of this is if I want to show you how a data frame works, I'll just copy this code, select this code and say Control Enter. It'll only run that portion of the code. So that's the advantage of it. So firstly, let's create a vector. You can create a vector by using the combine function, and you can give in like colors there. So basically, I just gave in red, green, and yellow. So you create the combine function and then you print it out. So what happens in this case is it'll print out the colors. The next thing is you can also say, you can also ask it like what is a class, because the reason we ask this is because you don't know what you're combining here, right? The interpreter does it on runtime, so you don't know what is the class of this particular variable, what is assigned to this particular variable. So you have print class of that. So you do Control Enter. It'll tell you it's a character. So what all, everything which you're entering here are characters. Similarly, you can create a list. The list is again, if these arrows are confusing you, just use equal to signs. I just want to show you arrows because that's how R was started initially, because they're like, oh, they need to know which has been assigned to which is kind of very, I think like very basic, everyone would know that. But so what we do there is basically in list, you can actually, I can just run this thing. I can combine a vector, I can combine a float, and I can combine a mathematical function also and put it in the list, because list doesn't need to adhere to anything. So you can see that it is basically there. And if I print this list, I send you this code also in case if you're not writing, it's fine. But then this, it'll print out the list. It'll say that, oh, first element in the list is this vector. Second element is this float. Third element is basically a function, which is called sign. So, and then comes matrix. So why do we use matrices? Matrices is when you have rows and columns, right? When you have n rows and m columns, you basically create. And for everything, you use the combine operation. Like in this case, I want to create 2 rows and 3 columns. And I'm saying that by row equals true, which means that I have 6 elements and I want them to be entered by row. That means the first row first, second row next. So, and I'm populating 6 elements by giving a combine operator here, A, B, C, B, A. So all these are 6 elements, and I print out my matrix. So this is the standard for creating a matrix. But then an array can have multiple dimensions. So why do we have an array and a matrix? So in matrix is just 2-dimensional, right? So basically you can have n rows and n columns, but an array can have more than 2. Like in this case, I have my dimension. So even mind you, that's why the C combine operator is so powerful, because for everything you can use C. I'm saying that the dimensions of this particular array is 3 comma 3 comma 3, means it's a 3-dimensional array in which you have uh, 3 arrays of 3 by 2 dimensions. So you can create multiple dimensions with an array, and then if you actually give it a value, it will repeat them for you. Like for example, in this case, I'm giving green and yellow as my values, and I'm saying please create a 3 by 3 by 3 array. So when you print that out, you see it has created an array which is basically 3 by 3. So 001, 002 has been printed out. So you're creating a 3 by 3 array and 2 of them. So here, so this is the rows and columns, and how many of them do you want, right? So I want 2 of 3 by 3 arrays. So first 3 by 3 array is, it's just repeating what I've written here. Green, yellow, yellow, green, yellow, green, yellow. That's the first array, and the second array is again yellow, green, yellow, green, yellow, green. So these are just the basic primitive types, and how do we create them? So I think just code this part, like just create a vector, create a list, create a matrix, and create an array, so that you just familiarize yourself with how to write the code in RStudio. Then we'll talk of the other 2 data types, which is factor and data frame. These are the only 5 things you need to know. You don't need to know anything more than this. So that's why R is very easy to learn. It's like one of the easiest languages to learn, because it's just like, it's very interpretable, right? So you just start giving a vector and assigning it to some particular variable. So for now, create a vector, put in anything in it, create a list, so print them out, create a matrix, and create an array. So I think Satvik is asking what makes R special for data science and analytics. Firstly, I would say the ease at which you can code in R. Like, I mean, because it's a new language, but once you're familiar with it, it's very simple to create matrices, very simple. So if you're actually writing C# or Java, right? If you want to create a matrix, you have to like initialize a double dimensional array, and then say number of rows in that array, number of columns in that array, and run a for loop to populate it. But in this case, it's in one statement you can create it. Right? You can just say matrix and then do this. The other reason why it is special about data analytics, because it's a language designed only for data. Like you basically don't use I mean, it's not used for creating like web services or backend, front end, and stuff. For that you have the regular programming languages. So it's only used for data analytics. One, because of that, and second, it's the ease at which you can import and export data. So we have one more R file here in which I'll show you how easy it is to read data from a matrix, or how easy it is to read data from databases and stuff. So it has a lot of functions where you can read stuff from databases and this thing. And also the modules. You have a lot of modules for doing data processing, statistical mod. So technically you can argue even Python has that. So I'm not comparing. So my favorite is Python because it's very, I feel it is, I'm more used to coding in Python. But R, it's for a scratch work. Like it's like this, right? So when you're in an exam, right? I don't know like how it is here, but let's say you're given a division problem. So we used to always have this scratch table or something which we write as a rough work. So in the rough work, we do all our rough this thing, and then we come and finally write our main division, how we did that in the main paper. So R is generally used for that scratch work because it's very easy to do all this and use these modules and stuff. Once you are comfortable, or once you see that the data is data can be processed in R really fast and easily, then you come and implement it in production. So that's one of the reasons why it has been famous. Does that answer your question, Satvik? The more we see, the more we will see. It's very easy to install packages. It's very easy to like. It's very easy to like load. So the whole, again, these things and all, what main thing which you need to take away is how to load packages and how to use them, because we'll do the whole linear regression tomorrow and logistic regression tomorrow. They both boil down to 1 or 2 lines of code. It's called LM, which is linear fit, and there's logistic regression. So the coding aspect of it will be really simple, but then the whole thing is, how do you install those modules? How do you actually pass in data to those modules? How do you create the data frames? So even data frame, so we've not gone to data frame, but there are 2 more things. If you're finished with array, matrix, list, and vector, we'll go ahead and learn the other 2 data frames, other 2 data types. So is everyone getting outputs? Is everyone able to play with this thing? So if you want to run only one section of the code, just select that code and say Control Enter, you can run it. Any issues so far? For people who have joined a little late, I just sent out an invite. I just sent out the 2 links. I'll send them out again. So to install R and to install R Studio. So the first link is where you install R, and the second link is where you install R Studio. So once you actually install both of them, it's relatively very simple to use R Studio and stuff. Any questions on is everyone's output working? Is installation successful?
I simply type and try to run, but it gives me some different output.
So where are you running it? Are you running it on the console or are you running it as a script?
I am running it in a script.
So you created, right? So first file, new file, and then you created an R script.
Oh no, I haven't stored it. I just type and try to run. So I have to save it, right?
No, you don't need not save it. You can just run it without saving. But the thing is, so console, you can run everything in. So console, you'll see down that it will execute one thing individually. But in case of writing with a script, you can basically go file, new file, and then create an R script. When you create an R script, you will basically find a new page opening, and you can just type everything here. And then there are a couple of ways. So don't use run. Run will only run one line of the code. Wherever the cursor is, run will run only that. But if you hit source, it will run the whole thing. If you hit source, see, it actually runs the whole file for me, like what all I've given here. So let's start with the basic vector, right? So create a vector and say C. You can, I'll also maybe type it here with you. So I just say even underscore numbers. And I'll assign it C 2 4 6 A, and I'll print it out. And then I'll just select this and say Control Enter. You'll see the execution will happen down here in the console window. You see whatever I've selected, that will run here. So just ensure that this is running for you. How about you guys, Satya, Satvik? Are you able to run them?
Yeah, it's running for me.
Yeah, it's running for me too.
Okay. So vector list. So Jatin, is this running just these 2 lines?
Yeah, that is running, but I'm getting before the output, I'm getting like source active RStudio document, and below the output, I got a hash mark create, and some other code is coming up. Mm,
Are you looking at the console only, right?
Yeah, I'm looking at the console only.
So let's clear the console. Nothing CLS clear. I forgot what is the command. There's this thing here. So there's this broomstick here. You can click that and it'll clear the console. So click that broomstick on the right. So you can see one broomstick.
Yeah.
Just clear it. So clear everything, and now go back to your R script, whatever you have created,
Yeah.
and just run. And just so click on first line. You hit run. You will see that the first line executes, and then you hit the run next time. The second time, second line should execute. Are you
Oh, yes.
after doing that also? If you're getting this, then there's something wrong with. Did you install R?
Yeah, yeah.
Okay.
Okay, now it's coming. Now it's coming.
Okay.
Now it's okay.
So I think maybe there's something. I'm not sure. Something must have happened. But anyway, so going ahead from like the basic data types. So we did a vector. We did matrix. We did an array. So an array, you actually define your dimensions and you just given your whatever you want. You basically will do. Then you can print with that. But there is something called as a factor object or a factor variable. A factor variable is interesting. So factor variable, basically it is used for knowing the frequency. Like for example, I create a vector in which I have like green, green, yellow, red, 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 green. So now this is basically having green repeated it like 3 times, red repeated 3 times, yellow repeated once, right? So whenever you create a factor variable, what it does is it tells you like how each of the element is a factor of the whole thing. So what it means is like if I actually create a vector which actually has multiple values and then I assign a factor variable, I say factor and I give it that vector. So when I print it out, it's going to give me levels. So when I run this, so it first creates the vector, then I create the factor variable, and then I print out that factor variable. So in this factor variable, it prints out the whole thing, but it has something called as levels. Levels is the distinct number of each item, and it'll tell you like if I print out levels, it'll tell you number of levels will tell you like how many of them are there. So it'll give you like distinct number of individual entries. So it's just another variable if at all you're trying to do like a frequency table or something in which you want to know the unique number of things, right? So instead of creating an array and then asking for a unique count, you just send it to the factor variable and it'll give you like each individual one. So it'll tell you like what green is and like how number of levels in each of them. So it's just an additional data type, not useful that much. But the main data type which is useful is data frame. So data frame is, we have seen Python data frames, right? So it's the same thing in R. So a data frame consists of a key and their values. So the way you create a data frame is you say data.frame, and then you open braces, close braces, and then you can give in your key and their values. So the most important function in R is this combine operator. You use them everywhere because that's the thing which will tell you that combine from here to here and put it in gender, combine from here to here, put it in height, combine from here to here, put it in weight, combine from here to here, put it in age. So a data frame is just as we have seen in Python also. Data frame is nothing but it has each column, so in this case, this is also a column, right? So if I print this is the gender, height, weight, and age, each column and its values. So that's what, I mean, it's very similar to like the Python data frame which we had. So if I run this and I print it, so you see that it has created columns, gender, height, and weight. And then each of them, it has created the corresponding values in it. So data frame, so data frame is the one which we use to read from CSVs and stuff. It's similar to Python. So these are the 5 basic data structures in R. So, and those are only the slides I have, because the rest of them we are going to code and learn from now on. So is everyone clear with the basic data structures or data types? I mean, not data structures, I'm sorry, data types. So data types, we don't need to exclusively mention any data types. Like we don't need to say string equals this, or like int equals that, because that's interpreted. So interpreter, when it's executing, it will actually take that value and put it at runtime. So we don't need to exclusively mention that. But at the same time, there are these data types which are useful for data processing. Out of them, vector is the first one. Second one is basically a list. And then matrix, array, factor object. Sometimes you can use it whenever you need like levels. But the main thing is data frame. Data frame you actually create. Let's create a data frame. So I think just so that you have some practice with it. Create a data frame of, like, I mean, you can use the same one which I have, or you can just create a data frame with so this is your data. You need to create a data frame from it. So what is it that we do? We first identify its unique columns. We say gender, height, weight, and age are its unique columns, and then we give it the data in each column. The way we do it is we create a data.frame and then give it the column name and then its values. Next column name, its values. Next column name, its values. Next column name and its values. So that's how we create a data frame. So please create a data frame and print out the data frame. The cool thing is, right, as I told you, right, so you can write everything in one R script, and then you can just select this and just run that. Or you can just click your mouse cursor here and run this function run. It'll run one thing at a time. So if you want to run the whole thing, you hit source. So if we are done, so if we're done with the basic structures, what we will see now is, I wanted to actually do this thing. How do you read from the command prompt? So the way you read from, sorry, is this done? So is everyone able to print out a data frame? I'll just wait for a minute. So we'll do small examples. We'll do that, and then we will see how to read from the console. Then we will see how to run loops, like print out for loop, if loop, and stuff. And then we will see how to do data sourcing. So data sourcing is how do you read from CSV files? How do you read from Excel files? How do you read from data connections? You can even read from URLs. You can even give like, oh, I want this URL. I want all the text from it. You can read from URLs. So we'll see how we do that. And then we will see how to install modules, how to uninstall modules, how to write basic functions. And yeah, and then the next thing is plotting. How do we plot? How, like the similar plotting which we did in Python. We did bar plots, we did histogram plots and stuff. So in this case, it's very simple. It's just one line. You just need to import the module and run that line. So is the data frame done?
Just 2 minutes.
Yeah, sure. So while you're doing it, I'll just show you what is on the right side over here. The right side, you can see they're like different windows. So there's one window here, which will, so plots will show you all the plots which you have plotted here. So it won't pop up another window, but it has a window called, so when we do plotting, you will see all the plots here. And then if you hit files, it'll show you all the files which are there in your current folder. Packages is thing one where you can search for a package. So if you don't type in, it'll show you all the packages which it has. A package is nothing but the one in Python we have used NumPy, we have used pandas, all those are packages, right? So these are also packages. You can see all the packages which R has. So you can see that all the plotting packages, all the things are here. So you can search for a particular package. Let's say if I want a package called rcurl. I already installed it, that's why it's not showing. But let's say if I want a rules. See, it shows you a rules. So, and then you can just click on it and then say install from here. So that will install this thing. But right now I'm not using it, but you can just directly use the a rules package by clicking it and then just typing whatever you want from a rules. Anyways, and then there's a help window. The help window, you can type in anything. So let's say if I don't know what factor is, right? I just say factor. It'll automatically pull it from, it'll automatically pull it and it'll give you all the documentation from it. A function factor is used to encode a vector as a factor in terms of category and enumerable types. The argument is ordered. If the argument order is true, then the factor levels will be assumed to be ordered. So things like that. So basically, and it'll show you a usage of it also. So is this factored? Is it ordered? How do you actually, so we saw that how we created a factor variable, right? We passed in the whole vector into the factor variable function here. Similar to that, you can actually pass it in here and then it'll tell you what arguments are and stuff. So it's really useful whenever we don't know what each of them does, you can just type in help and you will do that. Above here, there is basically history. The history will show you every command you have typed in the past. So the thing about history is you can actually click and then you can actually run it from here also. You can reload that particular. So let's say you were writing something in the script here and then you forgot what was that function. So you can go to history and you can find it'll I think preserve I don't know, it'll preserve a lot of history, like around like 500 previous commands and stuff. So you can load it from history and then run it again. You can actually pass from history to your console or to your source. Let's say, oh, I want these 5 commands which I actually forgot, right? So I can put my cursor here and then I can put this here and then say transfer it to the source. So you see that particular command came here. So if there's a syntax error, then it will show with the cross because data frame needs to be closed. That's why it's a syntax error. And then you have connections. The connections are another cool stuff. When you have like a SQL connection or something, you can create a new connection here. So I can create using Spark or like a standard ODBC connection, like database connections and stuff. So it'll install the packages and then so that's why like it's really cool to like work with data. Like Spark is another thing where it'll install the corresponding packages and then you can connect it with the Spark database or ODBC, general ODBC database and stuff. So this is what is there in here. You can create a new project and then do it, but we're just doing scripting for now. So anyway, I think like you must have finished data frame, this thing. So let us go to like, how do you input from the command line? The way you input from the command line is by saying prompt read line. So you want to read line and then you want to prompt what you have to enter. Like for example, if I want to run this, I want to print my name. So I just will say control enter. So it'll say read line means reading it from the command line. And prompt means what should it display here? In this case, it says prompt enter your name. It says enter my name. And whatever is the input to this, it will go and print it in my name. So now I press enter. So it's done. So now you have to go down and say So mind you, this is because I'm running it in the console, but if you want to run both of them together, you just hit this and then say, or do control enter. So it'll print out your name and this thing, and then and you want to store something like, oh, one thing I wanted to tell you was variables, right? In variables, you can have a dot in your name. The reason for that is, uh, let's say it's very readable, right? So all this is part of me, my name, my age, and this thing. So that's why I have my dot name, and then I have my dot age. So variables can have a dot in their names. So you have my dot name, and you can read from the command prompt and put it there. My dot age, you can read from the command prompt and put it there. And then ultimately, the command which we did for string formatting, it's called paste. So you say paste what is my name? Next year you will be my age plus 1 years old. So if you run all of this together, it will basically tell you. So this is how you actually run it from the command line. So it'll say, I think it's because it's running from source. Let me run it like this. Enter name. Oops. So when you click source, so I'm entering my name. Next is enter age, 30 years old. See, he Sankalp, next year you will be 31 years old. So that's the output you will get. So how do you read line from this thing? So you basically give read line and give it a prompt, and it will basically take your inputs and then you'll run it. So that's pretty much how you do read line. This is simple, so we don't use it. I just want to show you how to read line. I'll send all this code again, so you need not worry about that. After this, let's just do some loops, because after any questions so far? Any questions on how we are reading or how we are? So,
I just missed the beginning for the command line execution.
Okay.
So just type down like my string and then print my string.
No, this one?
Yeah.
No, this was just the first step, right?
Okay.
Where you actually assign your variable that name, and then you print it out. So this one was just to show this thing. You need not write this thing. I will send this code. Like, we'll only do the basic stuff. So this is just to see how you can read from the command line. So you just so the main command for reading from command line is read line. In read line, you actually say you prompt to say whatever is this thing. So when you run that, you will actually see that it'll prompt, say enter your name, enter this thing, and it'll print it out. So this you need not do it in class. I just thought I'll let you know how you read from the command line.
Okay.
So what we'll do in the class is when we write functions, we will do before we write functions. So I have like some simple functions for you. So we will write some functions in the class, but before we do that, let's just finish some basic thing called loops. So all right, ignore the first part. So first, this is the whole thing. So loops, right? So in loops, we have main loops, which we have is for, while, and if loops, right? So how do we do if loop? So before we do loops, there is one thing which so just as we had the combine operator, we had C, right, for combining. This is very useful. It's called sequence. So in sequence, what you can do is you can give it like start and end, and you can say how much you can increment it by. So in the sequence operator will be very useful if you want to like run a for loop over certain numbers and stuff like that. So sequence is something which is very useful for for skipping, or you can basically increment by 1, increment by 2, and stuff like that. So if you have like a sequence, like for example, if I have X, let's type this thing. Let's just do like some basic for and if loop. So in this case, I want to actually print out all the multiples of 4 in 0 to 10. So in 0 to 10, how many multiples of 4 are there? 4 and 8, right? 0, 4 and 8. So for that, what do I need to do? So I need to run a for loop. So basic for loop syntax is, you say for, you give it a variable I in this particular X. But what is X? X is a sequence from 0 to 10 with a step of 2. So first let's create a sequence of X. So if I run this, Control Enter. What happened? Let me just clear this. All right, let's just run. So you see X actually has a sequence. So X is 0, 2, 4, 6, 8 and 10. So the sequence function is really useful in R, where you can actually run something with steps. So if you want to print out every even number, every odd number, so if I do it by 3, then it will print out, it will increment everything by 3. So let me do that. So you see it will print out everything by 3. So the sequence operation is generally used for stepping. The reason we do that is because for operation, in generally, how do we write that in Java or C++, right? C#. So we say for int I equals 0 semicolon I less than 10. Then we say I equals I plus 2. So this is how we generally write a for loop in, obviously this is not valid in R, but this is how we write a for loop in other languages. But in case in especially in R, we actually, so what are we doing here? We're trying to run from 0 until 10 or maybe until 10, and we want to increment it by 2. So instead of doing all that, you create all this thing in a variable called X. So how do you do that? Using the sequence operation. Sequence, you run from 0 to 10, and then you say that you increment it by 2 or this thing. So that's exactly doing what this internal to for loop is doing. So you first create that, and now X already contains these operations. So then you say for I in X, means that this I will take each value of X every single time it goes through this loop. So instead of creating like I runs from 0 to 10, you say for I in X. So that means that when first time the value of I is basically 0, second time the value of I is 2, third time the value of I is 4, next it is 6, 8 and 10. So what is the difference? Like what do you see the difference here between for loop and in Python and in R? You guys did for loops in Python, right? In Python, we actually had everything based on indentation. We didn't have brackets, but R has brackets. So that's why we actually, so in Python, it was based on indentation. You give a colon, and then based on the indentation, you can actually run through the for loop. But in case of R, you have to give for I in this thing, and you have to give opening braces and closing braces. And if statement is very similar. So you remember this operation, it's called modular. Modulus means that if I is divisible by 4, then it will be 0. So if not of that, that means that it is basically, or you can do this, or you can just say if I divided by 4 double equal to 0, then you print out that it is a multiple of 4. So for loop, if loop is very simple. If something, then print. For loop is, instead of running for int I equals 0, I less than something I plus plus, you first create the whole thing in a variable called X. What will help you do that? That is the sequence operation will help you do that. So when you have this sequence, it will run from 0 to 10 with step of 2, and then you create for I in X, and then you run your loop. So basically, this is how a for loop and if loop works. So if I run this code, So multiples of 4 are 4 and 0. So basically it is trying to find out all the multiples in this thing. But wait, why is this is wrong, right? There should be 8 also in this. Oh, that's because last time I ran it with 3, so I only has. So let me run this whole thing again. See, now 0, 4 and 8. So now you have all the 3 multiples of the same. So quickly write this function for like just to familiarize with for and if loop. So the only difference in the for loop for other cases in this is you first create the whole iteration. You first create the whole iteration of x, and then you iterate each one in x. So the syntax for the for loop is for any variable I in some sequence variable. So in this case, I've used x, but I can use something like my sequence. And then I can actually create my sequence using the sequence operation. My sequence equals sequence. Let's say if I want to print out all multiples of 10. So I will say sequence seq 0 to 100 with a step of 10. And then I can say now if, let's say if I want to print out something which is only divisible by 20, I say if I modulus means reminder, right? So if I modulus 20 is double equal to 0, then you will print I. So that if let's say print I, and then there you go. So that is your for loop. Run that. Single time it creates this. Let's run that. So it'll print out all the things which are divisible by 20. Can you guys run that? Any questions on for and if loops? So it's the basic building loops, right? I'm just showing you the syntax in R.
Oh, no questions this time.
Okay, were you able to run these things?
Yeah.
Okay, so let me ask this question right now. So do you guys want to code along with me, or should I just show you the code and you guys can pick it up? I just want to know what is the best way, like because these are very simple concepts, right? Do you think coding will help you familiarize with the syntax, or should I just show you, like should I just show you how it is done, and then you like, and then you can, like, I'm just trying to see what is a better way. Like complex stuff, maybe I can ask you to code, but simple stuff, should I just do it myself? Or do you guys want to code along with me?
I think you can send it to us, and if we have any questions, we can ask the next class.
Okay, I think, yeah, that will be good because these are simple concepts, right? So I'll do that then. So I will actually just type myself. So Jatin and others, do you think that's better? I can show, I mean, I can run the code here, write it, and go along with it, like how these loops work, and I can send you the code. And then if it doesn't, and then you can run it at home, and then you can, or do you want to code? What do you feel, Jatan? You want to code or should I?
Yeah, I think you can continue because these are simple concepts. We can
Yeah,
take
I
care of
think.
it later on.
All right. Yeah. These are like simple things. So main things when the main concept of this is just familiarizing with the R language, so that when we load modules and stuff, we can just call it. All right. So similarly, while loop, right? Again, while loop is basically uh, similar to like other concepts. So while something, so in this case, I've actually combined three concepts. So I'll talk about functions in a bit, but in this case, what I did is I've actually uh, created a function which will say read line, please enter your answer. So while the answer is not 42, I will keep uh, I will keep prompting again and again. So when I do that, so while something is not equal to this thing, I'll say print, and then I'll say please enter the new integer. So like you can see there are a couple of concepts in this thing which I had written here. One is has integer. So the reason we have to do this is whatever you type in the command prompt is a string, right? So if you want to typecast a string into an integer, you can just do as dot integer and then put it into your response. So and then it'll go up again and check if your response is this. So in this case, let me just quickly run this. Oh, it doesn't find response because we have this. So I'll just do control enter. Object response is not found. Oh, it's because I've given read integer, so I have to do it the whole thing. I better run it. So run. So please enter your answer. I say 60 some and month 6. Enter. Then I'll here. And then I go through the while loop. Is it 60? No. Then it will basically come back and again ask me, sorry, the answer you to whatever the question is must be 42. So now when I do 42, it'll finish off the code. So basically while loop is similar to this thing, but before before we continue further, this is how we write functions in R. The way we write functions is, so in general, right, in let me compare with Java or C#. In Java or C#, what we do is we create a function by saying, okay, is it like static void, or we say void my function, and then you give it like some prototype, right? Like you say int x comma int y, that's your function, and then it'll have no return type, that's why it's void. In case of R, what you say, so basically function itself is a keyword. So when you have something like my function, it's so everything in R is like you're assigning something to a variable. So when you say like so this is my function, and then you assign, you can either give equal to, or you can use the arrow operator. In the arrow operator, you say that what is this thing? This is a function. And then the function basically has parentheses. You can define your function here. So this is how you will define like what your function basically is. So you basically, in this case, I've actually said that I'm reading from the command line. So I use prompt and then I give my answer. So that's how I define that function. So any function in R is basically defined by using my function, and then you give it a function name, and then you assign it to that particular function. So my function is a function name. So then you can actually call it like, you can call it like a function, but the way you create the function is by calling the function name. So you say function and then you define your function here. So that's how, so this is like, they're like small differences. Like I know the syntax is a little difficult for the first time, but the more you code in R, the more easier it gets with how the assignment operator works. So these are the differences. Like in other languages, you just create a function with parentheses and then you pass things to it. In this case, you create a function with a function name, and then basically, you can actually give it some names and stuff. So again, for loop, basically it's always for k in something. Either you create a sequence or you write 1 to m, and then you can then basically loop through that thing. So there's no continue in R. So instead of continue, they use the word next. So these are like some of the basic looping and function stuff, but we'll go into functions a little bit in detail. So in functions, as I told you, so basically first function which we saw is sequence, right? Sequence from 32 to 33. This is a function. Mean of couple of numbers is a function. So sum of something is a function. So if you run this, that's how you call functions. See, sum of something is a function, mean of something is a function. But how do you create these functions? You create the functions by saying, like, let's say if you want a function in Java or something called new function with value a, it takes an int value a, right? So but since there are no data types in here, you don't have to give that int and something of that sort. So what you do is you basically say that this is my new function name, and then I create my function with which takes in a, and then it will do this particular thing for me. So what this does is, like, it in this case I'm just printing out all the squared, like 1 squared, 2 squared, 3 squared up to a, and then I'm also printing out the sum from 1 to this thing. So this is how I create my function. So in R, everything is like an assignment operator. So this is my new function, but what does this do? It is basically a function. So you say a function, and then what does it take? It takes an a, and then you create that function, and then use a for loop, if loop, or something. And how do you call that function? You basically call the function as like any regular operation. So you basically use, so here I'm printing out 1 squared, 2 squared, 3 squared. So I do that and then press enter. You see 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and then ultimately I'm printing out the sum from 1 to a. So actually, let's write a function. So I think functions are little difficult, or like I think functions need some practice. So here's the function you need to write. Write a function which takes 3 variables, and you have to print out which is the greatest of the 3 variables. So basically what you do there is you have to create a function. Let's say function's name is largest value is the name of the function. You define a function which takes in 3 variables, and then the function will output the largest of the 3 variables. So now you will actually use an if loop, and you will actually create a function as well. So let's do that. And this is a sample example of how you will create a function. So create a function called the largest variable or largest value. It takes 3 numbers, and out of the 3 numbers, it will print out which is the largest of the 3 numbers. Is that clear what we need to write? So first step is, how do we actually define it? So we have to first assign a function. So first, if it's a function, it has to take function keyword, and then we have to take in 3 variables, a, b, c. And now our function needs to define which is the largest of these 3 variables. So how do we do that? If a is greater than b and a is greater than c, then we'll print paste A plus is the largest. If not, so since A is not the largest, then we just check if B is greater than C and B is greater than A. Then we do the same thing. If this is not the case, then we just print else. Just print C is the largest. Just say if you can use paste if you want to paste a variable, right? If you want to paste the value of the variable, you can just use that. Can everyone write this function? Just so that the syntax of the function is clear. How do we create a function and how do we actually run it?
Yeah, I understand it.
But just write it,
Mhm.
not like just so that you know how to write a function, right?
Yeah.
So we create a function by saying function and then take 3 variables, and then we do an if loop to check each of them. And if A is greater than B and A is greater than C, then we say A is the greatest. If B is greater than C and if B is greater than A, then we say B is the greatest. If A and B is not the greatest, then it has to be C, or else we'll just print out C is the largest. Only thing here is like you create a function by actually assigning it 3 operations there, and then we get this thing. So this is a quick way of like how functions are written in R. So remember in Python, we did functions without arguments, we did functions with arguments and stuff. Similarly in R also we have that. So in R, if you want to give function without argument, just give it blank parenthesis, and then it'll print out everything, and then you can do whatever you want without arguments. If you want to send a function an argument, you just send like A, B, and C, and then that'll print out that for you. But they're also like optional. There are functions which actually have default values also. When you create a function in which you actually have a default parameter. Let's say if there are 3 values and if you pass only 2 values, then the third value can be assigned default. You can just say if no one passes the value for C, I'll say C equals 5. That way you can basically use default arguments for the parameters. You can also give named arguments similar to Python, where you can say when you're calling that function, you can say B equals 5, C equals 3, and A equals 11, just for named parameters. We did this in Python, right? So where you can actually have named values for each of the functions. Yeah, so and yeah, default arguments for functions, and it's pretty much these things. So functions have default arguments. You can also pass the function named arguments and stuff. So that basically is like how functions are defined in R. So now that we have actually, is that clear? Any questions on functions? So we saw data types, we saw loops, we saw functions. Any questions on functions? No questions? Is it confusing to learn a new language at this point, or are you guys feel you can pick up one more language now, or?
I think it's fine to learn one more.
So yeah, this is one, yeah. So this is actually useful because once you actually start data science, right? So you can, people generally use both R and Python. So it's actually useful to learn R also. So so these are the things which are like the standard types. So let's actually go into plots. Before we go into plots, let us actually see. Okay. Before I go in depth into plots, I want to show you something. So basically, there are packages in R, like similar to how we have packages in case of Python. So the way we use those packages is basically like, for example, if you want to do linear regression, or if you want to do something like, for example, in case of data read, right? So let me show you how do we do that. So if I want to read a PNG file, right, there is a library called PNG. So this is the package I need to use. So the way I do that is by saying that, hey, using this library PNG, this library needs to be there. And how do I install PNG is like I go to packages and then I search for PNG. See this package right here? You just click on that and then say install. Goes here and say PNG. It basically goes and then installs that package and then refreshes your R session with that package for you. So either you can do it using graphically by saying go and install something, or you can just go and directly type PNG as this thing. So it downloads it from CRAN. It basically uses it, and now it is basically taken it. So you basically once the package is installed, the way you reference it in your script is by just calling library this thing. So this is a package used for reading a PNG image. So you say library and use PNG, and then it reads the PNG image for you and it stores it in this particular thing. So let me just show you how this works. So you just call this, and then so I'm reading that PNG values here. See this is my image, and then I read that image, particular image here. So I can clean it, it'll remove all of them, and then I do it again. Control enter. I read that image and I plotted that image. So this is how the loading modules works. If you want to remove the module, you can just say remove packages. So remove packages, you can go and just type PNG. I don't want this package anymore. So it'll then remove it from your library. This is how you load modules and remove modules from R. So if you want a particular package, 2 steps, right? First thing is you basically use it in your R script by saying library, I want to use this library. Second thing you use is basically you have to install it. So install, you can either install it manually by saying install.package. So say install.packages, you can give it png. That will install it, or you can do it here in the packages folder. You can actually come and say install, and then you can basically use it from there. But in your code, just reference the library you want to use. So that way you basically can use that particular library for reading that particular PNG package into your file. So that's how you install and uninstall modules in your files. So I just want to show how do you install them. So once when we do plotting, so we might be using some of these libraries in here. So let's look at how we plot. So plotting is like similar to like in Python. What do we have for a plot? When you have a plot, you actually have the x-axis, the y-axis. So first command which we learn in plots is basically the name of the command is simply plot. So in this case, what do you give in x-axis and y-axis? You give vectors. Like in this case, let's say if I want to I have a variable called cars, and I want to just plot that particular graph, that particular variable, right? So what will I do here? So I create a vector of cars, and I give you the different number of cars. I have 1, 3, 4. Let's say these are the number of cars available in different 4 rental places. So first one has 1, the second one has 3, next one has 6, 4, and 9. So you create a vector of cars, and then you plot them. So in plot, plot has like different plot has different metrics. So first and foremost, type can be like the one. So let me show you this thing. Let me just plot it, and then maybe that'll be, so when you plot it, all the plots come in this plots section of your image here. So in the plots, you see now it's 1, 2, 3. So I have like so this is the number of cars, and this is the index of the car, right? So the first value is basically 1, the second value is 3, the third value is 4, and then you have 9, right? So you see that if I actually give it the type as 0, it is going to give me zeros here. But similarly, if I give the type as X, it's going to give me X's here. Let me just run this. Control Enter. Oh, sorry, I don't think it has a type X. You can give it dashes. You can give it O or dashes. So in the other case, or you can actually replace it with something called as PCH. So PCH, if you actually go and like look up the R library, so in R plot there's something called as PCH. PCH means that instead of you specifying what you want to actually plot, you can specify a combination. So like for example, 0 means square, 1 means circle, 2 means triangle, 3 means plus, 4 means cross. So, and also it will come with different shapes and stuff. So if you say PCH 22, it means it'll plot a square with the color blue. If you say PCH of 21, it'll plot circle with the color blue. So depending on the kind of plot you want to use, you can actually use that in R. So like for example, in this case, I have truck. So I want this thing, but I can override it with PCH. PCH is actually going to tell me 22. That means it's going to be a square, blue square, which is going to be plotted like this. So you can specify what you want to plot using the category called PCH. And also you can specify the type of line. So this is line type 2, line type 1. Line type 1 is dashes, line type 2 is solids, and I can change the color. Like for example, in this case, if I want to like plot trucks, so I do this. So line type 2 dashes, right? So I actually have square using the PCH. It overrode this type 2, and then I actually changed the color to red. So the whole thing is red in color. So this is how you can plot different kinds of graphs and stuff. So if I actually change the line type to 3, so let me change the line type to 3, control enter. You see this has become slightly bolder than the previous one. So if I go back and change the line type, so you can always look up the documentation here. You can go to help and say LTY. LTY will give you like, so search string, or you can look up the thing in lines. So lines, it actually has different types here, right? So here it will tell you in details like which one will give you what. So you can take the references here, and then so line width will be the width of the line. If you want a thicker line, you can give line width. If you want a dashed line, you can give line type. If you want like a different like color of the line, you can give color of the line and stuff like that. So, and then you can give it a title also. Title is given by giving title, main, autos. Basically a column, you can make that red, and you can make the font also different. So when you actually run all of them together, so you have the title as autos, you have the font for this particular title as 4, you can give the color of the title as autos, and then each individual one you can tell you what kind of lines you want. So in this case, I think I forgot to give the line type. I think if I give the line type as 1, then it will be solids. Yeah, this thing. Now, the plot new has not been called. Oh, okay. So I need to give plot new. Let me clear everything. It's fresh. So the truck, see, and I gave line type 1, it's no longer dashed lines. It's basically going to give me solid lines. So there are different things in plottings and stuff like that which you can uh, run. Like the plot function itself has like a lot of things which you can take. Like in this case, if you give xlab means basically the title for the x axis, ylab means the title for the y axis, and you can give x limit and y limit. It's similar to like what we have done in Python. So in this case, y limit is the extent to which it has to plot the y-axis from 0 to 12, right? So in this case, because I have 1, 2, 1, 3, 6, 4, and 9, I actually have the number of cars limited to like 12, or else it will plot something up to 20. So x limit and y limit, xlab and ylab will give me the labels for both of them, like number of cars, index of the car, and then ylim will give me the limit for the graph. So if I do this, you can see. So the reason it's not plotting is because you need to give plot.new every single time you have to plot. Like in this case, where was the plot.new? So I give, before I do this, I'll give plot dot new, and then I'll give this thing. So it will refresh my plots. Oh, valid of type. Oh, I gave 0, that's why I should give O. Now let's run this. So as you can see here, y limit will give me the limit at which I have to stop my y-axis. So y limit actually gives 0 to 12. So x is the index of the car. So this is how you can specify what you want to plot. So the command for that is xlab and ylab. So just do a quick plot of, you can use the same thing, like give like the number of cars. Just be familiar with what you can give in this thing. So first, function in the plot is basically the data. Second is the type. Third is the color. Xlab means the x-axis title. Ylab means the y-axis title. Y-limit is the limit at which you want to restrict your graph from 0 to 12. Can you guys plot this? The main function which we use is called plot. We will be using this in the case study we'll see on Sunday. I think the case study will be more interesting because this is just teaching how each individual one works, right? See, we don't have a case study as such, but it's important to like talk about how plotting should work right now. Actually play around. Instead of a blue plot, you can actually use PCH and then plot red triangles on this plot. And how do we plot that? By using this thing called PCH. So PCH triangle is here. So you can give the triangle as 2, or you can give 24, and then you can change the color to red. So you see the explanation here. It'll tell you like each PCH value, what kind of triangles you can plot and stuff like that. So this is another small thing in PCH functions. You can use PCH to change the kind of plots you can plot and stuff. Can you guys do a quick plot? Just to get familiar with how plots work, where you see the plots and stuff.
Yeah, I'm doing one.
So
Can
you
you hear
create,
me?
create a
Okay.
vector. First is create a vector, and then basically give that vector as, so plot basically takes in the following things, right? Plot first takes in data, and then it takes in the type. So what kind of marker do you want? Like, do you want a circle? Do you want this thing? And then it takes in color. So Xlab, what does Xlab mean? Xlab is the title for x-axis. Ylab is the title for y-axis. And then you have xlim and ylim. So xlim means the range you want, range of x-axis, and then ylim is the range of y-axis. So you'll get more document if you actually type plots in here. You'll get more documentation if you want to add more things. So, and then you can add a title to it. You can add a title and say main, the title of that is autos. You can have red, you can have the font for it and stuff like that. So this is the basic plotting command. So I'll give you a minute to plot it. By the way, if you use asterisk, it's commenting the line out. So you, generally in other IDEs, you use double line, right? In R, you have to use asterisks. Satya, are you done?
Not yet. Just a few more minutes.
Sure.
Yeah, I'm done. And I got the
So you got the plots, right? So how
yeah.
this is here. Cool. So basically that is like the basic plot, but we have actually done more complex plots uh,
Python.
in Python. So we can do the similar kind of plots even in here also. So basically, for example, for creating a box plot, you just so you first create like let me show you how to create basically bar plots. So in this case, I basically have uh, so par is the one which can create like 4 plots in one. So you can create like 2 rows and 2 columns, and each of the row and each of the column you can actually create like scatter plots and stuff like that. So for box plot, the function is basically box plot, and you give it the value you want to plot in it. Histogram plot is also just hist, and it'll tell you what is the value you have in it. So for example, in this case, if I want to create like 4 of them, I want to arrange them in 2 rows and 2 columns. So you actually call it with a par function. Par means partition. You want to partition the graph into 2 by 2, and in which you have 2 rows and 2 columns and stuff. So this empty cars is basically you're attaching this empty cars is basically a data thing in R. So you can just attach it to empty cars package, and then you will get all the data from there. So if I run this thing, let me just run this. So I'm attaching to, so in empty cars is an inbuilt data package in R. So if you in order to use that data, you just have to attach to empty cars and then create a division of 4 by 4. So you can actually pull out this part out. Or let me just move this thing. So as you can see, it has created 4 plots with 2 by 2. So it's created a histogram. It has created a scatter plot. It has created, so basically if you have this is the, so empty cars is a data package in R which talks about the weight of the car and the miles per gallon. So you can use, and then weight of the car and the displacement of the car. So as you can see, like uh, basically mph is miles per gallon what it is. So this is the database which they have, right? Empty cars. So I just did an attach of that. I did a par function where I can split them into 4 graphs, and each graph I plotted something different. So for histogram, I just use hist. For box plot, I use box. So you can see how uh, this is the distribution. It's again the same thing. Like this is the mean of the weight of the cars, and these are the extremes of the cars, right? So we did box plots in Python. We did histogram plots in the same. So the idea of this is like any plot which we have done in Python and this thing, we can actually reproduce it in R. So the way, and the thing we did there was we tried to divide them into 4, right? The way we did that here is by using par. Par stands for partition. You can partition the graphs into further things and then do it. So we'll plot everything in the case study tomorrow, but this is how we'll generally start off with the case study. And so just to familiarize you with everything which we did in Python, we can do it in R as well. So the histogram plot, the frequency plots and stuff. So one other thing which this thing tells you is like if you have a data set in Python, you can just say attach empty cars, and then you can basically do it like this. So this is basically the plotting library. So first is the plot. It has different functionalities where you can change the color, the titles, the x limit, y limit and stuff. and the next ones are basically how we can plot like box plots, histogram plots, and scatter plots and everything of that sort. Scatter plots, you just have to say plot with what are the two variables you want to plot them with. So this empty cars, if you look at our data set, you will actually find the weight, miles per gallon, weight, displacement, and stuff. So you can actually do a scatter plot of them by just giving plot xy. Plot xy will give you a scatter plot of it. Plot his box plot of w will give you the box plot of this thing. So it's the same theory from like what we did in Python before on how we can actually do multiple plots and stuff. So I think it'll be good to just plot the four of them, right? So firstly, empty cars is the one which is basically there in Python. Just write the four lines of code so that you have a familiarity with how to actually plot them with like within a partition. So here, first step what you do is you attach to this particular data set. It's called empty cars. So first is that. Second, you create a partition of rows. So basically how you create the partition is you create 2 by 2, you create a vector and then say that I want 2 rows and 2 columns. And then for each of the row, it will be clockwise. So first it will plot here, second it will plot here, third it will plot here, and fourth it will plot here. No, sorry. First row, second row. So first, second, third, fourth. So first it'll finish off the first row and then it'll finish the next row. So when you do plot, you just in this particular data set, you actually take the weight and miles per gallon and you give it, the main is basically telling you what the title of the plot is. So you say scatter plot for weight and miles per gallon. Second thing you say scatter plot of weight and displacement. Third one is the histogram. So you actually just do weight and do the histogram of the weight. Fourth one is the box plot. So just try to quickly plot these things. And then we'll go into data sourcing, like how we actually read the data from CSV files. How do we read them from different, like from the URLs? How do we read them from text files and stuff like that? So that I think that'll be the end of this. So I know this has been a little, we are just introducing R right now. I was just trying to give as much insight as possible, just so that you're familiar. So the idea is not to like, oh, one day you'll familiarize and become a master in R, but just to give you familiarity as to how we'll code and this thing, right? So anything we did in Python, we can do it in R as well. The syntax is slightly different. I understand that, but it's again a choice of. It's good to actually have this basics somewhere recorded in your brain, so that sometimes when you refer to R code, it'll be useful for you if you want to like. It's just like R 101, not even 101, like the basics of R, so that in case if you want to pick up R for data science in the future, it'll just be a brief session sort of thing. So can you guys plot this thing? Plot like these four graphs?
Yeah, while you were talking, I just finished plotting.
Did you finish? Okay.
Yeah. Also, 2 questions. So why do people use Python instead of R? Because R seems much easier, right?
R is easier, but R has never developed into a production level this thing. So till date, like if you're a data science company, so you basically you still want to, because you can't export DLLs and stuff, and you need R to run on. So you see, remember when we actually did R, you actually ran R installation on your computer, and then you utilized all the programs and everything in R. So not a lot of machines run R as by default, right? Whereas Python is more widely used. So this is just picking up. So, but it's really useful for, as I said, right, for scratch work.
Yeah.
It's really useful for like quick data visualization, quick this thing and stuff. So when you're doing production, definitely you will either go for like Python or C# or Java. But if you want like do a quick analysis of your data science work, I think R is the. So as you'll see in the case study tomorrow, like we will actually do a case study on the number of bikes New York shop has to keep in store for depending on the weather and stuff. So we'll use linear regression to solve that problem. And you will see that it's easier to plot graphs in something of that sort. So you can basically get a feel of how to do linear regression quickly. But if you want to productize it, you just go back to like Java or C# or Python.
Okay.
So did you finish plotting it?
Yeah, I did.
Okay. Is there anyone else plotting? Or maybe when I send the code, it will be useful. All right. So we have like 15 minutes left. So this 15 minutes, I'll just show you how to use data sourcing. So data sourcing in R basically is how do you get the data from different sources, right? So data sourcing is basically one thing. So we need data sourcing most surely because we need to read CSV files, right? Like for example, I'm going to like show the biking data set tomorrow. So how do we read the data from different sources? So first source is CSV. So CSV, it's the same thing. There's a function called as read.csv, and you give it the CSV path and it'll read the data in that CSV path. So it's just read.csv. So you can see the whole data. Oops. What is, I think we need to set the current directory first. So this is all the biking data which we have. So first is we get the working directory. We set the working directory to this folder because this is a relative path, right? I didn't give C:R: this thing. So first I actually got the working directory. I set the working directory to this. Then from that you can give your relative path. So read CSV biking data dot this thing. Here is the data which we have. So this is a CSV file which you can read, and as you can see there, like a lot of columns, like what day it is, what season it is, what month it is, what weekday it is, what temperature it is. Like these are all the different parameters which we will look to and then see using. So remember I said regression is used for prediction of like given some other day what it should be. So that's what we will see in the class on Sunday. So this is how we read the file from the data, and then you can actually create a data frame from this data. So you actually say data.frame and you create the data frame here. You can find the max and min. So one thing in this data frame, once you read it, is the way you access columns is by giving the $sign. So once you have this data, you can actually say data $. So it'll give you all the column names. Similar to how I think even in Python, we were able to access the column name, right, by giving it a dot and this thing. So in this case, you basically give a $, to access the column name of that. So for example, if I want the max temperature of all the data, so I actually take all the column names with data $temperature and I take the max temperature out of it. I do Control Enter. So you see the maximum temperature. So this is normalized. So let's say we have the temperature in Fahrenheit, we take the maximum and divide it, and it's normalized. So this is the max temperature of this thing. So you can actually create subsets also. So you take this data and then you actually give me that particular subset where the temperature equals max temperature. So you can create subsets by saying, give me that particular subset where the count of the number of bikes is greater than 3000 and the registered number of people are greater than this thing. So you can retrieve subsets from a given space as well. So like in this case, if I actually run the subsets, so Control Enter. So this is the subset of all those things who have registered more than 3000 and who have registered more than 2500 and whose count is more than 3000. So basically this is the subset. You can take the data frame and create subsets as well. And then there is this package called XLS. So firstly, if I run this, I don't know if it'll run because we don't have. So what is this? This is reading from an Excel file. So for that, we need a package called XLSX. So in this particular package, if it is not installed, it'll give us an error. Let us see if it is installed. Oh, okay. So when you give library, it is basically, it says it is loading required package. So it is already installed. So it loads that data and then reads that data, and then this is the data we get from the Excel file. So how do we read from CSV? You give read.csv. How do we read from an Excel file? You say read.xlx, but for that you need the library called as xlsx. So once you have that library, you can actually read it. How do you read from JSON? So how many of you know what JSON is? So JSON is like, so generally in web services, right? So in web services, so whenever you have a web service, most of the time you have to pass the data to it, pass the data to the web service. How do you pass the data? The data is passed in a format called as JSON. JSON is generally, it's like a plain text file, or it's a notation. So it basically has like open bracket, close bracket, and then it has each of the data, like for example, name of a person, age of the person, and then like different things about that person. So when I want to send this to, like it's the same way in which you send your data to any of the web services or anything, right? So whenever you're calling like your Facebook endpoint or something, you're passing your username and password. So the way most of the web services communicate is by this format called as JSON format. So JSON, so generally XML was the format which people used to use before, but then now that's been replaced by JSON. So most of the REST endpoints, all the web services use JSON as the primary means of communication. So we use JSON to actually go and communicate, send the data across the thing. So if there's a JSON file, we can actually read the data from the JSON file by calling the function from JSON. So that will basically load the data from the JSON object. So you can see that. You need a library for that called rjson. So all the data in the JSON. So let me show you how the JSON object looks. Maybe that will be interesting. Scripts. Where is this rjson?
So JSON is a web services for data transfer?
No, JSON is the medium through which you transfer data to web services.
Oh.
So like for example, like how many of you know what REST endpoints are? So basically REST endpoints are basic, like, so there's I mean, I don't want to go into web services as such, but in general, right, every web service out there so every HTTP endpoint, right, either takes the data or gives the data. For example, when, let's say you take Facebook, for example. So I click on someone's profile, their page needs to load, right? If I click on my friend's profile. So what is it doing? It is sending the name of my friend to that web service, which will talk to the database and pass your friend's name to that particular service. So what happens there is, so basically you are there. Let me just talk about like how the web services work. So basically there is a web service. The web service actually is responsible for giving your friends data on Facebook. So this is a web service written by someone. So for this web service, how does it know which friend's data to actually pass? That comes from you. So you basically say, which friend. Let's say you have a friend named John. So you say that, hey, I want to get the data. So you're passing this data to this web service. How do you pass it? You pass it in the format called as JSON. JSON is the way you pass that particular data to that web service. In that, how does your JSON look there? It looks something like this. It says this and says friend name, something, whatever was the notation. And I'll say I want John, his profile. So you take this JSON packet goes through this web service and you say, hey, web service, give me this friend's output, like give me or show me the profile of this thing. So what does this web service do? It'll take this thing, it'll contact the database, it'll get all the information about John, and then the web service will basically give you back his data. And how does that look? That's again the format of JSON. So JSON is just a format, or a format of how the exchange goes. So it'll give you your friend John's info. And how will that JSON look? So it'll be a bigger JSON. So it'll be his name, it'll be his whatever is there on his profile. So who commented on it, comments. So I mean, I don't want to like go into details of what JSON is. You can just read it up on Wikipedia and stuff. So if you just type JSON, you'll get like a lot of information. So JSON is this whole formatting. You can read wiki on it to just understand. So JSON is the way how the communication happens. It's basically a data independent platform, how each web service talks to the other. So you can, it's now used like, so this is an example of JSON. So, oh, they also have the name John, that's good. So basically when I ask the request, it'll give back in this format. His name is John, last name is this thing, age is this thing, his address is this, his phone number is this. So this is a means, this is how the data packets communicate between web services and yours. So a lot of times when you're talking to web service, so R can also call into a web service and then it can get the JSON files. So in this case, I'm showing how to read that JSON file. So if I get the data, if I get a JSON file called data.json, I use this library called rjson, and then from that JSON file, I'll read the results. So this is how I do that. So if I do control enter, so it gets that JSON file, and it you can print out the whole data frame of that JSON file. So that's how. So there are different methods. Like we'll be mostly using CSV, but I showed like R service because it can. Sometimes you have to get the data from, like, let's say if you're doing machine learning on Facebook, right? So you can't store all the data in your on your machine, right? So what you'll do is you'll write a program to say, hey, web service, give me the data of John. So the web service will give you back this whole JSON object which contains that particular data, but you have to read that JSON object somehow, right? So that's how you use it. So you say from JSON, from this file, you actually load all the data and then you read it. So this is another way to read data from the web. So you can give it URL. So in this case, I want to get all the weather data from somewhere, right? So this is the URL. So if you go to this URL, there's all the weather data which is there. So I can just read the data from the URL also. So I go to this URL, I get all the HTML links, and then I detect which link is working. And then I want to see like the data from 2017. So from that 2017 web link, I can go and manually parse. I can go and manually parse the data and get each of the data files from there. Sorry, where is the thing? I can get the file name for each of that. So I can download the data from each of the links also. So there are different ways in which you can get data parsing into Python. So you can actually get it from CSV, you can get it from Excel, you can get it from JSON, you can get it from the web. So in this case, I'm actually trying to read it from this web service, from this website. I'm going and downloading all the data in this link, and then I can then pass it into this thing. If not that, you can also go and read it from SQL database. So in SQL database, you do a function called dbconnect. So I don't have the database running here, but this is the syntax for it. So you connect to that particular database with username and password, and then you establish a connection to that particular server, and then you can read the data. So that's how you can connect the data to the database. So R has different means of getting data from different things. Mostly, since we are doing like case studies in this thing, we'll use a standard CSV function for reading the data. So at this point, I'll give you an insight into what we will do in the next class. So we'll use R as a medium, but we will do regression. There are two kinds of regression problems which we'll see. So one is linear regression and logistic regression. In linear regression, basically what we'll see is, I think, let me, oh no, in bike sharing, here's the thing. So there is this data which we have from, so this is actually real data. This is the data of a bike storage shop. So what they collect is, they collect how many bikes do they rent every day. But the bikes they rent every day actually differs from time to time. Why is it not recording? Anyway, my Excel is not responding, but I'll show you the data in a bit once it, oh, here it is. So this is the bike data. So we have, so which season it is, which year it is, which month it is, whether it's a holiday or it's a weekday, what is the temperature on that day, what is the humidity on that day, what is the wind speed on that day. So how many people have registered for the bikes, how many bikes have been lent out. So this is basically for the whole year of 2011, we have the data for every month. So using this data for like 2011 to 2000, let's see how much data do we have. 2011 to 2012. So we have 2 years worth of data for every month. So using this data, we have to predict whether, given the temperature and like these parameters, how many bikes do they need to stock. This is like a very big rental company, bike rental company in New York. So we'll use a linear regression model to fit for these parameters, and then using these parameters, we'll predict how many bike rental places should we, I mean, how many bikes should they actually stock given different parameters, given different temperature, given that it's a holiday, it's not a holiday, and stuff like that. So most of the stuff which we will do is using reading from a CSV file, but these are the methods which you can use for reading from different sources. So you can read from as I said, right, you can read from a CSV, you can read from an Excel, you can read from a database, you can read from a JSON file, you can read from the web also. So these are different like methods you can use to do that. So yeah, so I think this lecture was basically to cover like the basics of R. Again, I'm not expecting you to be like proficient in one lecture, but it's a good start at least. So we saw how do we install R, what is the IDE to use R. We saw how do we basically load data from different sources. We saw what are the basic data types. We saw lists, we saw the other kinds of we saw lists, we saw factor, we saw data frames, we saw matrices, we saw arrays, and then we saw how to write loops, how to write functions, how to do basic plotting. So these are the basics of R that I wanted to cover. So the thing is, in case if you want to use R later on, I would still recommend Python, because that's why we did 80% of our classes we did in Python. But the other regression aspect of it, we'll do it in R, just so that in the future, if you need to use R for data processing and stuff, you'll have an idea as to where to start from. So because 80-20 was my division, right? So 80% of the case studies we do. So we have 2 case studies left. One is logistic regression and other is linear regression. So we will cover them the first thing in the next class, and then we'll finish those case studies. We'll show them in R. I won't expect you to code it because it'll take a long time. I understand R is new to you guys, but I'll go through the case study. I'll walk with you and I'll give you the code for that case study, and then I'll show you how to write a web service in R. So we'll create on the cloud, we'll create a machine, and then we'll port our code, whatever we did for linear regression, we'll put it on that, and we'll expose it as a web service so that someone else can actually use your service to call. Again, how will they send the data to the service? They'll create a JSON object and send it to that web service. Web service will take the JSON objects, it'll do the processing, and then return back the JSON object back with the results. So we'll see that on Sunday. And by the way, Sunday is our last class for this session. So if you have, I think we'll do a little, so generally it's 3 hours, but I think this Sunday we'll probably extend it to 4 hours, just in case if there are any more questions and stuff like that. So Sunday we'll have from 3 to 7 the class, because 1 hour I'll just teach about like what regression is, how do we deal with linear regression and logistic regression. Next 1 hour we will do the case study in the, of linear regression, this thing. Next half an hour I'll just show you how to write that web service, and I'll keep for one hour for more questions and stuff like that. So yeah, I think that's it for today's class. again, as I said, this is an introduction to R. It's not like it's not a thing where you be proficient in R, but I think it'll be a good start to at least learn one more language and it have an idea. It's very easy to learn. As you can see, we've covered so many topics in R in like couple of hours, right? So if you, and I don't think it is that difficult to follow. I mean, unless and until you felt it was difficult to follow, it was pretty much straightforward. The only couple of things is how do you create functions. The syntax is different, assignment operations is different. Instead of having equal to, we have these arrow assignment operations and stuff like that. But yeah, so that's pretty much an intro to R as such. Any questions?
No.
Okay. So I think if there are no questions, then I will stop the class here. But Sunday, yeah, it'll be maybe 3.5 hour class, just so that we wrap up everything and then answer any further questions which we might have. So I'll see you guys on Sunday then.
Okay.
Okay. Thank you. I'm ending the meeting right now.
Thank you. Bye.